All right, guys, so today we are looking at lesson 15.2, and that is understanding angles and unit angles. We're actually going to be looking at angles within a circle. Now, I kind of feel like the book really sort of just overcomplicates this skill. So for today, as opposed to looking at the book and going through and doing these problems, I am going to go through on a separate sheet of paper and model through some examples and take some notes for you. I just want you to kind of follow along and really pay close attention to what I am saying and the figures that I am drawing on the paper. And in the end, what I will do is take a picture of this completed page and I will upload it in today's folder for you. You can then either print it, or if you want to recreate it and copy it, I'm going to leave that up to you, or if you just want to reference it while it's there on the computer. But let's get started. So in fourth grade, I know we talk a lot about angles and the degree measurement of those angles, but you also have to know how to find degrees within a circle. So I know that Accoletics has mentioned this before. If we have one whole circle, right, and we're trying to find the angle measurement of that circle, one whole is going to be equal to 360 degrees. I know we've talked about, like McCoy told us, if you skateboard and you do like the full spin on your skateboard, it's called a 360. That is why. Now, you also need to know that half of one whole circle, meaning we cut this in half, is equivalent or equal to 180 degrees. And again, another skateboard trick where you turn halfway and it's called a 180. Now, taking one step further, if I take that 180 and I cut that in half, what does this angle measurement look like to you? That's right. This one would be equivalent to 90 degrees. And when you look, that would be cutting your full circle into 4 equal parts. So 1/4 is then equivalent to 90 degrees. Now, taking it even one step further, let's say that we split into fourths, knowing that these are all right angles. This is a right angle, this is a right angle, and this is a right angle. Now we want to take one of these fourths and cut that in half. So imagine drawing like a line right here. Well, if the fourth is equivalent to 90 degrees, then what would be cutting these in half be equivalent to? Right, that would be equivalent to 45 and 45. Now, if you imagine cutting your circle, well, each of those fourths in half, then I want you to think, how many equal parts would you have then? Correct, 8, because you had 4 originally. Now you have 1, 2, 3, 4, 5, 6, 7, and 8. Therefore, 1/8 of a circle is going to be equivalent to 45 degrees. Now, something that they may ask you. Let's say, for example, so using your background knowledge, you might be given a problem like this one. 3/4 of a circle is equivalent to how many degrees? Think about that one for just a moment. Well, 3/4 would be referring to this area right here, meaning if you cut your circle into 4 equal parts and you shade 3 of them. So now it's almost like you have to visualize cutting into fourths, and the degree measurements of each of those fourths we know is 90 degrees. So 3/4 would then be equivalent to 90 plus 90 plus 90, which you know is 90 multiplied by 3, and you know that 9 times 3 is 27, and then add on that 0 for a total of 270 degrees. So that's just some quick like background knowledge that you guys need to know. But now we're going to move into some sample problems. So in fourth grade, you have to be able to then do two things with this information. You have to first find an angle measurement or solve for the angle. You also have to solve for the fraction. So we're going to begin first by solving for the angle. So I'm going to focus in and zoom in on this sample problem, and I want you to read that to yourself. Okay, so again, I know I'm finding the angle because this question is asking me to determine the angle measure. And they are telling me that the angle turns through 1/6 of a circle. Right away, I'm imagining a circle and it's been cut into 6 equal parts, as equal as I can get them. Now, let's see here. This would be 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. But I need to find the angle measurement. So what I need to know is just like one of these pieces, what it's equivalent to. Well, knowing that I've cut my whole figure, instead of a rectangle, this time it's just using a circle. And I know that the circle has a total of 360 degrees, so I'm going to take my 360 and divide that by 6 equal parts. Now, I don't know that division right off the top of my head, but I kind of see a basic fact there. 6 can go into 36 6 times. Then I'm going to bring over my 0 for a quotient or an answer of 60 degrees. So I know that just one of these sections is equivalent or equal to 60 degrees. Now, that kind of makes sense because if I filled in all 6 of these parts, imagine like 60 in each of these, and if you add those together, they, of course, are going to equal 360 degrees. But now let's change this just a little bit because we always like to do that in fourth grade. What about 2/6 of a circle? What is the angle measurement of an angle that turns through 2/6 of a circle? Well, if we know that 1/6 was equal to taking the 360 degrees that we know and dividing that into 6 equal parts for a quotient of 60 degrees, and we now need 2/6, we're just going to add on that extra piece of the pie. So let's add 60 plus 60 to get a total of 0 in 1's place, 6 plus 6 is 12, 120 degrees. Again, just taking what we know about that circle and divided into 6 equal parts. And now what I need to solve for is 2/6. That's my 60 plus 60. If they asked me for 3/6, that would be equivalent to then one more piece of 60. And I know that would be equal to 180 degrees. So again, that's solving for the angle measure. So given the fraction, you have to find the angle. Now let's look at the reverse of that. This time you have to find the fraction. So find the fraction, oops, let me scoot this over so you can see it, of a circle that an angle with a measure of 45 degrees turns through. And again, how do I know I'm finding the fraction? Well, it says right here, find the fraction, and they gave me the angle measurement. Well, something that I know, if you recall right up here, our background knowledge told me that with a measurement of 45 degrees, I knew that 45 was half of 90. And if I think back to my circle here, I knew that when we would divide into fourths or 4 equal parts, those were equal to 90 degrees each, meaning 1/4 is equivalent to 90. Now, half of 90, right? When we did that up there earlier, didn't we say that this was a 45 degree angle? Do you remember that? And if we think about that, that's like cutting this circle into 8 equal parts. So a measure of 45 degrees is going to be equal to 1/8 of a circle. Now, again, we like to make this a little tricky. So let's make it a little bit harder. What about an angle measure of 120 degrees? What fraction of a circle does an angle with a measure of 120 degrees turn through? Yikes. Are you thinking the same thing I am right here? I don't know this one. All right, so how do I solve? Well, you want to think to yourself, I know that 120 is out of the total 360. And these are the degrees. The first thing we're going to do is reduce. Meaning, I take my 120 out of 360, and I see right away that there's 2 zeros, so I'm going to cross those off. Now I'm left with a fraction of 12/36. And I can think in my brain, how many times does 12 go into 36 without going over? Well, 12 can go into 36 3 times. So that would reduce to 1/3. Now, think about this for a moment. Does this make sense? If you have a circle, you're telling me that if you cut it into thirds, so kind of looks like a peace sign, that the angle measure is 120 degrees. So each of these thirds would be equal to 120. When you add those up, what total do you get? $360 degrees. I will post this page for you guys to refer to. You have a couple problems in the book, and we will meet at 2 o'clock to go over those. And you do have an exit ticket for today. Let me know if you have any additional questions.